All right, so in lab 4, we're actually going to be pretty much doing almost the same thing we did last lab in lab 3, but we're just going to actually build on it a little bit. So what I'm going to do this week is we're going to spend a little less time actually talking about the lab itself, and we're going to spend a little bit more time talking just about joins in general. We're going to talk a little bit about, how do you know when to do which join, and kind of just more some of the more practical stuff behind it rather than just talking about the lab. But we are going to kind of use the lab a little bit here at the beginning because I kind of just want to make sure that we talk about everything that's on it. And like I said, it should be fairly similar to what lab 3 was. The only difference is we're going to kind of go a little bit more, I guess we're going to get just slightly more complicated in some of our joins. So, and there are a couple steps here that have, and I've actually, I don't know if they're errors or not. I'm still waiting to hear back, but I actually think that the objective was with some of these is to have you reverse engineer a little bit from the results. So it's not explicitly giving you every little thing to do, and it's kind of saying, hey, maybe you need to add something based on the results. So that's kind of the way I am going to approach it as I explain it. So for step 1, we're just going to write a simple query, but it's going to return the unique member ID column value from the member table, where you use the last name column value of the contact table to find the distinct row in the member table. And you should use join the member and contact table using the member ID columns, which is there. So it kind of hints at this a little bit, and it says, use the last name column value to find the distinct row. So basically it's saying, hey, this is the output that we want you to get, so you need to get it. And I think kind of the exercise that it's wanting you to do here is it's trying to reinforce, do you know how to look up to see which last name you need to get member ID? And so just to kind of show you, how we would do that is if I wanted to know, which last name do I need to use for member ID 1003, I would first look in our contact table. I guess I should select everything from contact. And we know we're pulling member ID 1003. So if we look at this, okay, here's a member ID 1003 and the last name Sweeney. So I know we're going to use the last name Sweeney in our where clause. So on your step 1, you're going to write your joins, and then you're going to put where last name is equal to Sweeney. And so it didn't, and this one gives you a hint. Some of them aren't quite as clear about that, but just know that you might have to reverse engineer just a little bit because it's kind of going to just start making you work for it just a little bit more. And then on step number 2, we're going to write a query that returns the non-unique last name, account number, credit card number, and it combines that from the contact and member tables. Now, again, when we talk about non-unique, that means that we're not going to use that distinct clause. Up here, we had the word unique, and anytime you see the word unique, you know that you're going to use that distinct clause in your select statement. So number 2 is not going to have a distinct clause, and it says you find the last name column value that matches a case-sensitive Sweeney string. Case insensitive. And you'll notice that this one is all uppercase. So you can use that uppercase function. Let's hurry and do that. So if we were going to say select everything from contact where upper last name is equal to Sweeney. And so that way it doesn't matter, how their name is capitalized in the database. As long as you put upper in front of it, then you can just do it in all uppercase and it will be case insensitive. So that's how you're going to do that one. And I'm not really talking about the joins right now because we did talk about that last week, and we're going to talk about it a lot more as soon as we kind of go over these different steps. Step number 3, you're going to return a unique last name, account number, credit card from the contact and member table. So almost the same thing again, just a little different. So I'm not going to go over that one too crazy. Step 4, this one is where we're going to start, I guess you could say, getting a little bit more complicated, because it wants us to return the last name and the account number. So and credit card number, city, state, province, and postal code. So we're taking, basically we're going from 2 tables to now we're going to be joining 3 tables, and we're going to show some examples of this again. And then it wants us to find a unique row, so distinct, where the last name column value matches a case sensitive VSQL. So that one's going to be in, as far as homework goes, the first time you join 3 tables. And then step number 5, you're going to actually join 4. So this one's going to get, again, just a little bit more complicated. And you'll notice that it actually, it says this solution builds on the solution from step 4. So you can actually probably take your step 4, copy it, and just add it. And we're actually going to talk a little bit about that, because we're going to do a query that's actually going to do a join between all of these. We'll do something similar. And I actually really like these problems because they're very real. So you can see that the output we're getting is a last name, an account number, a credit card number, and an address. These are things that you would probably pull, like if you were in the business, let's say you were sending out a mailer, you probably wouldn't include the credit card number, but, last name, account number, and address and all that kind of stuff is something that you're probably going to pull pretty frequently. So this is a great example, and this one's actually very realistic. So, it shouldn't be anything too crazy there, but it is 4 tables. But the nice thing, and we'll talk about this, the nice thing is with those joins is as long as you look at them each individually, it's not too bad. All right, and then step 6, this one, again, gets a little bit more crazy because we're going to go from 4 tables to 5. And those 5 tables are, the first 4 tables are all there, but then we're going to add this telephone table. And so you should see all the same information, but instead of the credit card number, we're going to add telephone number. But to get that, we have to do 5 table joins. And then for the, let me hurry and make sure we didn't miss anything here. Oh, we'll talk about that. So nothing too crazy there. And then step 7 is basically step 6, but it wants you to just remove the where clause so that it outputs it for everybody. So step 7 is almost a freebie. You just delete 1 line of code, and you're on your way. So anyways, let's dive into some of this other stuff. Well, we're going to actually just talk about doing multiple table joins again. I know we talked a lot about it last time. So if it is repeat, just be patient. It'll be a good review. And I know I got a lot of questions about, when do I use this join? How do I know which join to do? And so I'm going to try to go over that again. Hopefully we can try to help you guys get more comfortable so that, if you were just to say, oh, I need X, Y, and Z, that you don't even have to think about it and you can just know right off the top of your head which one you're going to do. So anyways, what I really want to do first is we're going to kind of just do a join. We're going to start off with just 2 tables and we're going to just build on it. We're going to just do a nice long query with lots of tables. So we're going to start off with the member table. That's kind of our parent table. And the reason it's the parent table in the hierarchy is because it doesn't have any foreign key values. Well, it does to the system user table with the created by and last updated by, but as far as our context of our business, it doesn't have any information that it's really dependent upon, such as contact is tied to member and telephone is tied to contact. Member is kind of like up there in the food chain. So we're going to start with member. So we're going to select, and what do we want from member? Well, let's get the account number. So we're going to select m.account number from member M. And I always like to kind of just start slow and then build upon as we go along. So, yep, there's our account numbers, 8 rows selected. We're good there. And now what we're going to do is we're going to join up to our contact table. We want to see, let's say, the last name of the people that are here. So I'm going to use an inner join because we want matches. So in this case, I'm saying, look, I want everybody, regardless of whether or not, or I want everybody who has a membership and a name. And the reason we're going to use an inner join on this is because technically, with our business logic, we would never have a membership that doesn't have a contact. So we're going to do an inner join to contact C, and we're going to do that on, and then this is where we take our primary key from member. So if we look at member, member ID is our primary key, m.member ID, because we're looking for that common denominator. And so let's look at contacts. Let's describe contact. And we can see that contact has a member ID. So we know that that's kind of the avenue to get into contact. That's how we can match those values up. So we want to match contact and member, where m.member ID is equal to contact.member ID. So let's try this. Oh, and we forgot to add it to our select list. So let's hurry and add it here. C.last name. There we go. Now you'll notice here that we have duplicate values. Even though, we only see, we know that the first name would probably be different, but you'll see that on Sweeney we have pretty much the same information here, and we're only going to pull the last name out of contact. So if we want a unique set of rows, because we don't want any duplicates, we can say distinct right there. And what that will do is it will take our 12 rows and it will bring them down to 8. Because, these 3 rows of Sweeney become 1, because once it prints this one, it says, oh, that's the same line that I've already printed. I'm not going to print it again. Now, if I were to add the first name to here, even with the distinct clause.
Can I ask a quick question?
Sure.
On distinct, does that apply to the whole row in general, or is it a single column, or?
It's the whole row in general.
So if you have 2 rows that are exactly the same, it'll only pick out the first one.
Yep.
Okay.
Yep. So so just like in this case, because we ran distinct with this one and we got it down to the 8 rows, if I add the first name here again, we're going to get all 12 again, because now, the Sweeneys, even though, before we cut those down just to 1 Sweeney record, well, now we have Megan, Matthew, and Ian. And so that row is no longer unique. Now each one of those rows is unique. They're not duplicated anymore. So yes, the distinct applies to the whole row. When you put it distinct in there, it's going to check it against the whole record. And so that's why sometimes you have to be aware of what information you're selecting, because if you want, sometimes you have to leave information out. There's also a lot of times, one of the biggest cases, I guess, as an example, when I have to be careful is with like a date, or if there's like an unexpected bit of information that I don't realize is going to be different, but ends up being different. A good one, for example, that I actually just came across today is I was pulling ACT information for students, their scores, for some analytics, and I was pulling their ACT scores, but this whoever entered that data, even though it was all from the same test, you take your ACT and you have your overall score, but then you have your math and your English and your science or whatever. I was under the assumption that the dates would be, because in my database I have a date field and it's actually a date time. So it's the date with the timestamp. Well, what I'm guessing is that the ACT score was manually entered, and whoever was putting that in must not have put it in all at once. They probably put in like the overall score, and then later in the day put in the math, the English, and whatever. So when I was pulling it, I expected the date to all be the same. So I put date in my select list right in here. But when I pulled that using distinct, I got duplicate records because all of a sudden the date, the timestamp was not the same for all the records. So, anyways, that's a good example. So yeah, sometimes you have to watch that, and whenever you're getting duplicate records, you can actually just look through your output and find which column it is that's, I guess, ruining your results for you. So good question. So let's take first name off there because we just want the account number and the last name. So that leaves us, and I'm going to run this again. So we're down to account number and last name. So now what we're going to do is we are going to tap into our address tables. Now our address tables, there's actually two of them, which sounds kind of silly. So if we look at first we have the address table, which is great. And you'll notice if we look in here, we have city, state, and postal code, but we don't have like a street number. So then if we look at our street address table, that's where that information is. And, I'm not exactly sure why they chose to do this, but I can tell you what it allows us to do. Because the way you design your database is going to essentially have effect on your business logic. So in this case, what this allows them to do is it allows them to have multiple street addresses that are tied to one address, which is kind of weird. Like I said, I'm not entirely sure why. The only thing I can think of is that if you were like a red box per se, you could have your hierarchy to say, okay, we have, I'm going to use Rexburg, Idaho as an example. Rexburg, Idaho would have its own address record for every contact. But then your street address, you could basically have multiple locations all tied to the same address if you had multiple houses in the same city and state. The other thing in this kind of structure would make more sense if you were red box, like I was saying, and you were using this table format to track your boxes, where your actual locations are. And so I'm not quite sure why they did this work, because these ones are tied to a contact, right? So this is only for customers. But if we took these address and street address tables and used them for like red box vending locations, then it would make more sense, because then your address table, you could say, oh, in Rexburg, Idaho, what are all of my locations? And then you would have all your street addresses, something like that. So you can kind of see how the way they design things have different effects and consequences and benefits and stuff like that. I'm guessing that they set it up here just to give us a little bit more exercise in doing joins and stuff like that, but it also might have just been because they used the same format somewhere else in another database where it made more sense. I'm not sure, but it works. And sometimes it's really nice just to separate data for all of us who are OCD about making sure everything's super, super nitpicky and clean. So nothing wrong with it, but it does allow you to do things. Like I said, if you wanted to have multiple street addresses tied to the same city, like if you were Redbox, that's the kind of design that you would use. So now that we're here where you want to pull address information. Now, in this case, I'm pretty sure everybody has their address, but let's say that we have some people who don't have an address. And I'm actually going to simulate that here for us because we're actually going to put my record inside of our member table and our contact table. So that way we can test this because we're going to have a little fun showing you, because right now everyone pretty much has a match. But I kind of wanted to show you more about when things don't have a match, because it is very possible not to. So first things first, we got to put my information in here. So let's take a look at the member table, and I'm going to real quickly insert my data in here. I'm going to insert into member. We're going to insert
Can I ask a really quick question while you type that up?
Sure.
Are you going to count off or on if we do an inner join versus a left join and get the same results?
No, unless it explicitly said, I don't really, because to me that's like what coding's all about.
Right.
Is finding fun ways to do the same thing. So no, I don't really care necessarily about how you get there, as long as you get the correct results. Unless it's like a big thing where, because obviously we could select all this data raw, which would defeat the purpose of learning joins. So, like as long as you're following the spirit of the exercise, I don't really care how you go about doing it as long as you get the correct results.
Okay, thanks.
Yep. And so I guess since we're here, I'm going to insert some data into the table. And we do this using an insert statement, which says insert into member. And then we put the values that we want to insert into in the row here. So you can see here, I am going to check what some of these values are because I'm going to copy these. And our singleton accounts, which ones are those? I've got to see which one's the individual account. Okay, so 1004 is the group, so I will be a 1003 because there's only going to be one of me. All right, and then my account number, we're going to say something like that. I don't know the format of the account numbers. My credit card number is not going to be my real one. Credit card type, we're going to say 1007. And then I'm going to just put in those. Okay, so let's make sure that we can insert into member here. And my account number apparently is too large because I think that let's change this to US, something like that. There we go. And now we need to do my insert into contact. Because basically what we're doing here is I'm going to insert my information in here, but I'm not going to put in my address and telephone number until later. And then that way we can see what happens to my data since I won't have matches across the tables. So we're going to say contact s1.nextval for contact ID. We're going to say the member ID is .curval, contact type 1002 it looks like for everybody. Normally you'd write little subqueries there to pull those, but for the sake of time, I'm just going. All right, and then created by. All right, so now let's re-pull what we had here for this, because now we should get my information here. So now you'll see there's my new record that is in our table there. So now we're going to start playing with this because that's the only two tables that I have information in. So let's say that we were to use an inner join, and we're going to join that with the address table. And we do that on c.address or c.contact ID is equal to a.contact ID. And let's pull the state. And city. Let's pull them both. All on the same line here. And we'll concatenate those together. And we'll call it location. So now you'll notice that here, because I am not in the results, and that's because we use the inner join, and the inner join is only going to show records that have a match. So we're only going to see records that where contact ID is equal to address ID. And just to kind of show the point here, I'm going to add those two columns right here at the end. And this is, if you ever need to troubleshoot, I still do this myself because sometimes I'm like, well, why are they not showing up in the results set? And so then I'll put these here because they should match up, but sometimes they don't. So here we can see that all these match up. But if I change this inner join to a left join, you'll notice that now I show up here, but you'll notice that my contact ID and address is empty. So that's why when we were using the inner join, it didn't show up. And you'll also notice here that we get this weird little comma that's all by its lonesome, because this is null or empty, comma, null, empty as location, which we could fix. You know what? Let's yeah, we're not going to worry about it right now. So anyways, if we wanted to pull everyone, regardless of whether they had information in address, that's how we would do it. Now what we're going to do is we're going to add a phone number to all this. But let's take off our contact stuff down here that we were using for troubleshooting. So we want to add the telephone information to our export here. So let's take a look at telephone. And you'll notice that telephone is tied to both address and contact. Now, the reason they tie this to address is because if you are a multiple home owner, you could have a home telephone number at each house. And so that way the phone number would be tied to the location. Now, that's a little bit dated methodology because, I doubt there's very many people anymore that have a phone sitting on the handset in the kitchen, like we probably all grew up having our parents do or whatever. Because now everyone just carries a cell phone. So I am going to just tie it to contact, which works the exact same. Unless someone has multiple addresses, which throughout the whole term, we never have someone who has multiple addresses, so we don't need to worry about it. But so I'm going to tie telephone to our contact table. So I'm going to take, and let's see what happens if I do an inner join. Now this one's kind of weird because, you know, we're at address. And I remember when I was first learning joins, this kind of threw me off just a little bit because I thought that I would have to go from address to telephone. But we can skip that because we have all of these columns. We have all of contact, we have all of member, we have all of address. So I'm going to inner join to telephone T, and we're going to do that on, and we're going to tie it to contact, just like we talked about. So we're going to say c.contact ID is equal to t.contact ID. So really, we kind of did this join to address, and then once all this is together, we have member, contact, and address, then we just tie telephone on there. But we can choose whichever column out of everything that exists from member, contact, and address to connect it to telephone. So in this case, we're going to go all the way back to contact to tie those together. So let's see how we did. Oh, and we need to add telephone to our list here. So let's add t.area code, concatenate that with a dash, and t.telephone number. And we'll call that as phone. So now we have the account number, the last name, the location, and phone, but you'll notice that I am not in the result set, right? So this is where we have to be careful about which joins we use because I don't have a telephone record. And so because we did that inner join, I now don't have a telephone record, or I'm not included in the result set. So we have to change that to a left join because we want everything on the left. So, and by the left, basically it's because we're going from all of this to telephone. So telephone's on the right, everything else is on the left. And we know that and this is where I like to build them slow so I can see, because I know I was in the result set as of here. So then we want to get me, even if I don't have a telephone record. So let's try that with that left join. And now you'll notice that we get all 9 rows, including myself. And again, with the weird dashes, which we could fix, but I am there. So there's that. And then that's 4 joins right there. So now let's say we want to take this one step further. We want to tie to street address. Well, street address is kind of there by itself. So we're going to leave telephone where it's at. We're going to do our left join to street address because it kind of just hangs off of address. I'm going to just call it SA. And we're going to say where on a.address ID is equal to sa.address ID. Now this one's interesting because if we take a look at street address, we have it just tied to address and not, if you remember, telephone was tied to contact and address. So one of the things we could do with telephone, and you'll find that many times you actually have to, not so much in our database, but sometimes you actually have to use 2 keys. So let's say we want to guarantee that our telephone number goes with the correct address since we're pulling that information. If we want to add some extra, I guess, clarity, because let's say someone did have 2 addresses. In fact, let's just simulate that a little bit. Let's select everything from address. All right, so let's say, let's add my address in here now since we've tested that a little bit. Let's say insert into address. And the contact ID is contact curve out. Type is 1008. City is the big old city of Afton. Tell you what, our zip code is. And see, this is where, like, is the zip code alphanumeric or is it just numeric? So let's take a look. Address, zip code, postal code is alpha. No. Yep, alpha. So we will put that in there as a string. And the reason we need to know that, if we need to put a quote around it. So there's the zip code for Afton. And then we have our one cystate. All right. So now we have an address that's there. Now let's say that I also want to put in an old address, because let's say that for whatever reason I never cleaned up my profile, and I also used to. Oh, I cannot remember the zip code. 84340. That might be Rexburg. I don't know, but no matter. So now I have two addresses. So let's run our stuff here again, and let's see what we get. Because now I should show up twice. You'll notice that I'm here in Afton and here in Lehigh, Utah. So now let's, just for the sake of being able to see this better, let's order by, let's order this just a little bit. There we go. So now you can see my two records here. Now let's go ahead and add one phone number for me, because we are gonna, and I'm getting to the point here, I promise. And then it was all right. So then so we go from contact. There we go. Telephone type is 1008. And our area code is, let's put USA. Area code is 307. Is that all varchar? Nope, that is yep, varchar. So 307. And I put these on YouTube, so I'm not going to put my real phone number, obviously. And then just our WHO audit information, which is our 1 cystate 1 cystate. And that 1 cystate, that just tells us who created it, when they created it, who updated it, and when they updated it. So let's go ahead and put my phone number in here. Oh, and I did something wrong here. Let's take a look. It says too many values. So I have telephone ID, contact ID, address ID, telephone type 1008, country code USA, area code 307, telephone number. Right there. Duplicated that for some reason. And there we go. So now we have my telephone number in there. Let's see what we pull. So here you'll notice that I have my phone number is listed twice here because I have two locations. Now, according to our database structure, if we take a look at telephone, our telephone table has an address ID in it, which means that we are tying a telephone number to an address optionally, right? Because you'll notice that this one says it's blank on, it doesn't say not null, which means that we could have left the address blank. Well, my address has an address, my telephone has an address ID, right? Let's pretend that that isn't my cell phone number. It was an actual physical phone that I had when I was in Lehigh. So what we want to do is we want to make sure that that phone number is tied to Lehigh and not tied to Afton, Wyoming. So what we're going to do is we are going to, under our left join to telephone, we're just going to add one more thing to match on. So we're going to say and a.address ID is equal to t.address ID. So we can add multiple things to join on and run this. And so now you'll see that we're only tying the phone number to Lehigh and not to Afton. So that's how you could do those. So now let's add our street address information because we have our location. And let's change our thing here just a little bit. We're going to pipe. So we have city, state. Let's add our street number. Now I can't remember what the name of the columns are. So street address, that's what we're looking for. So sa.street address. We're going to pipe that with a space. And there we go. So now we can see the people that have street addresses in there have theirs. We never put my information in the street address, so mine are just still the city state. But that is a total of, you can see we went from member to contact to address to telephone and then to street address. So that's 5 tables that we have joined up with there, all using the left join. Now, because I have my information now, let's say that we expect everybody to have their address. Well, we could put an inner join there on address now and run it, and I'll still show up because now that I have an address, it doesn't matter if I put left join or inner join because it's going to pull the same results. So that's why it's important that you understand the design of your database and what's expected, because let's say that your boss said, hey, I need everybody in our systems, last name, location, phone number, because I have to send them all and let them know that we're going to be closed for Christmas, or we're getting audited by the IRS and I need to have everybody's information there. That's, I guess, the most stressful thing about if you pursue a career in databases. And really, I think this applies to anything technical, but specifically for data jobs, you're kind of the one responsible to make sure that data is accurate. And, all it takes is one little word different, something like this. If we were to say inner join on street address, and we only have 8 records, so we're pretty comfortable knowing that something's wrong. But if you have millions of records, then you're probably not going to catch it. And all it takes is that one little mistake on which join you use, and you're going to give someone the wrong information. So it's really important that you understand what those do and when you should use them. And and that sort of thing. So inner joins are for if you can guarantee or if you only want ones with matches. So I guess a good example is if I'm trying to pull ACT scores for averages. Let's say that I want to take everybody's average ACT score who's taken it and figure out what the average is for a school. Obviously, if they haven't taken it, then you can't put that into your calculations. So an inner join is appropriate because we only want the people with scores. Another example is that if you're doing an inner join and you want to send a text to everybody, and so you pull the name of the person and their phone number. If they don't have a phone number, you don't care to pull them, so you use an inner join. However, on the side effect of that, if you want to see how many students have registered for school, have a registration application for school, you would want to use a left join, because if they don't have one, that's kind of what you want to know, is you want to know who has an application and who doesn't. So then you would use your left join. And with that, the right join is just the same as the left join. It all just depends on which order you pull from. So for example, on telephone, we could have said select from telephone T, right join, contact C, or similar. So it does the same thing as a left join, just the other direction, if you want to start from the other table and work backwards. But anyways, that is pretty much, like I said, it's kind of hard because there's not too much new, so I kind of just wanted to go over some bigger select statements. And this one should come in handy for some of the stuff. And we're going to put an inner join here because it really, for yours, it won't matter too much. Does anyone have any questions about any of this fun stuff? And I guess as a better question, is there anyone who still feels like joins are just still mumbo jumbo to them? I feel like from the previous instructions, they've really done a better job of slowly working you into how they work. You start with 2 tables, and then you move on to 3. And like I said, the nice thing is with joins is you can build them. They're like little modular bricks, in my opinion. And once you get one to work, then you can just look at the next little bit of information you need. So like, just like how we added one little column at a time that we wanted to add, we just add the join for that. So I hope that it's all made sense. No one said anything yet, so I'm taking that as okay, so you didn't get them last week, but you're getting, yeah, and that's kind of the whole idea, is we should be getting more comfortable. And this lab is going to do, I guess you could say, less hand-holding as far as trying to explain each individual step to you. And it's going to kind of give you the reins just a little bit more. It's not going to shove you off into the deep end of the pool, but it is going to expect you to kind of explore a little bit more on your own.
If you have a minute after this particular meeting, I have a real world example I'd like to get your opinion on.
Okay, yeah, sure. Yeah, absolutely. But that's pretty much what I had as far as my examples go, because like I said, a lot of this is actually just reinforcement on this last week. So not too much new. Oh yeah, so can I explain order by 1, 2, 3? So so far we've kind of been using order by, and we'll put like a column name in there, which we could do. But a shorter way, the only problem is there's, like everything, there's a negative effect of taking a shortcut. So what this does is by saying 1, 2, and 3, I'm saying order by the first column, the second column, and the third column. So basically, it's the equivalent of saying order by M dot account number, C dot last name. And the reason I did 1, 2, 3 is because I don't really want to put this in the order by clause, because otherwise we'd have to do that. So essentially it's the same thing as doing that. The only difference is I'm going to put 1, 2, 3. Now the caveat to doing 1, 2, like I said, the negative effect is if I go 1, 2, 3 in my order by, right, everything works great. It's ordering just the way I want it to. It goes account number, then into last name, and then location. However, if I decide that, I want to put C dot first name, now it's going to order by M dot account number, first name, and then last name. So if you want to keep your ordering regardless of what you put your order of columns as, then you need to hard type the names. Otherwise, you can use first column, second column, third column, or whatever. So like in this case, if we wanted to keep it the same way we had before, we could just go 1, 2, 4 instead of 1, 2, 3. And then it will order by account number, first name, and street. If we want to keep it the same as it was before, we'd go 1, 3, 4. Account number, last name, and street address or location. Good question.
A question for you.
Yep.
When you name something as location or as phone, can't you, when you order by, just type in location or phone as that part? I feel like I did that last week and it worked. So instead of 4, type in location.
It always changes from database to database. Let's see. So yeah, that does work. So yeah, you could just put what you put in your as there.
So that could change from database to database. All right.
Well, yeah, like because like in SQL Server, Microsoft SQL Server, I can't remember if that works or not. So yeah, I'm not entirely sure off the top of my head. I've always used for stuff like this. I rarely sort by this kind of stuff, but because like I guess for example, with this street address, normally what I would do is instead of even putting location, I would put order by SA dot street address, SA dot city, SA dot state province. So I always have, I don't know if it's, and like I said, I can't remember off the top of my head if there's a database system out there that doesn't allow you to do that, or if it was just out of habit. But I've always done this, but the other works in Oracle, so feel free to use it. Oh, and that's not a selected expression, so yeah.
All right, thank you.
Yep. Perfect. All right, any other questions? All right, perfect. All right, so unless you want to, and I forgot who was talking that said they had a real world example. I don't know if you care that other people here know about it or whatever. But if you want to hang around, okay. If you want to hang around, oh, yep, go ahead.
I'm sorry, this is Barbara Rambo out in California. I got a quick question. And maybe you've already touched on it somewhere and I just didn't hear about it, but I printed everything from the last couple of weeks, the lab and all the instructions and everything, and I'm finding that the lab and all the supporting paperwork don't match. Should we not be caring about that supporting stuff listed in there? You know what I mean?
Yeah, because and I've noticed that and they told us that was going to be a little bit of an issue because they just changed all these labs, but the reading materials still kind of, I guess, followed along with the other labs, because in the previous labs, we would actually be, in this lab, we'd be doing a lot of insert statements versus select statements. So
Mhm.
in the reading, that's probably what you've been reading about, and a little bit about database design. And so basically the way I would handle the reading is I would use it more as I would brief it over, because we are going to get there eventually. But it's not something that you need to necessarily commit entirely to,
Okay.
especially with the book. When it comes to the book, and I think I've said this before, that book is a developer's handbook essentially. It is not a read from front. You know, you don't start at chapter 1 and read through it. You could if you wanted to. However, basically the way that I view it, and I think the way the course is built, as an expectation, is it's there. So when you come across something that you're fuzzy on, maybe go look it up in the book, and it will explain it in great detail. Because that's the one thing. Because that book, I used to be like, oh man, this book is it's a, I don't know the right word. It's a lot to take in, that book is. But then I found that if I just took
Oh,
it
yeah.
in bite-sized chunks, like how does a sequence work? Go look it up in the book, or the distinct clause. If you're wondering, the distinct clause, that book is amazing because it will tell you everything you need to know about that distinct clause.
Right. What I'm actually looking at is slightly different. Maybe I'm not being clear on what I'm after. I'm trying to get logged in right now. If I look on week 5, well, okay, for the sake of get back in here. If I go into the correct week,
You are breaking up just a little bit.
I'm so week 4 summary and tutorial, and then it has the lab and the lab description, help section, and instructions. And that is nothing like what the lab is.
Yeah, so those are the old labs. So yes, you don't need to worry about those kind of things.
Okay.
Yep, don't worry about all the lab related stuff on there and the lab helps. Yeah, don't worry about those at all.
Download the lab and call it instructions that apply Oracle text that we get each week. Download that and use that.
Yep. And yeah, so what I would do is, as far as the reading goes, is I would make sure that it's, as far as what's on McLaughlin's website, and there might still be just a few artifacts in here every occasionally, but most of this, like these readings are really good.
Mm-hmm.
So I would just focus on this stuff. Occasionally I will point you to McLaughlin's blog, because there are some really great resources on there as far as the articles go. But as far as these anything in the tutorial section or the lab sections, don't worry about, because those are all old.
All right. Thank you. I appreciate.
Yep, no problem. And I guess as an additional, a lot of these now are, because they switched some of the ordering here. As far as his website goes, a lot of these aren't going to match up with what we're doing anymore. So like I said, for right now, I would just stick to the reading assignments that are in here in Canvas, because it should all be there. And I believe that the actual wording should be the same text as what's on the website. So just in the correct order now. Good question. All right. Well, if anyone else has if no one else has any other questions, I guess we'll go. If you want to stick around and listen to us talk about a real word example, then go ahead. But I am going to end the recording unless anyone else has any questions. So I'll give you one last chance. Any last takers for questions?
I have a question, but it can be after the recording.
Okay. All right. Well, if you need to take off, feel free, and thanks for coming. Otherwise, stick around and we'll talk a little bit more.